Imagine a world where lightweight materials are as strong as steel, but as light as aluminium. A world where planes, cars, and even medical implants last longer, perform better, and weigh less. You would think this would be far from reality, maybe too big of a step in today's technology.
But what if it were told you we are already creating such materials right now using cutting-edge nanotechnology? Aluminum alloy have been lying the backbone of industries like aerospace, automotive, and construction because of their lightweight nature and corrosion resistance. But they have one weak nature. Major.
They aren't strong enough for high stress applications. So what we did was sit and think, how can we change this? And how can we change this in a way in which it can keep its lightweight aspect, stay corrosion resistant, have the same, if not better, strength capabilities as steel, but not increase costs?
And I tell you what we came up with. The answer lies within surface composites. We came across a material called as silicon carbide or SiC. We found that we can reach our exact goal when adding these nanoparticles to the surface of aluminum by using a method called friction stir processing, or for short FSP.
And while these may just sound like big fancy words, I assure you there are more than that. And we're going to help walk you through what they mean, their significance, and what they could do for the future of materials.
So, what is the FSP method? We turn to the traditional method of improving metals properties, and so oftentimes that it's just mostly involve melting and remelting, which can introduce cracks, porosity, internal defects, and in general, a lot of bad problem you wouldn't want to have it.
But FSP gets rid of all of that.
A solid state process that improve metal without melting them.
FSP is a technique used to modify and improve the surface properties of materials.
Now, the process happens in three main stages. First, plunging, where a specially designed rotating tool with a pin and shoulder is pressed into the surface of aluminum, and the friction generates heat, and so the material around the tool softens.
Then, the processing stage, where the same rotating tool now moves along the surface, steering the material. And with the SiC particles added beforehand, they get mechanically mixed into the metal. This refines grains, reduces porosity, and distributes the SiC particles evenly.
Finally, the cooling stage,
Where the tool is withdrawn and where all the goods are made. Since no melting has occurred, the process zone retains fine grains, improving strength, hardness, wear resistance, heat resistance, and many other features while still maintaining almost the same weight with little to no more preparation and cost. That is why this method is so revolutionary. It allows us to embed nanoparticles into the aluminum matrix evenly without changing the material's core properties.
Now, before we dive deeper, let's take a step back and look at the bigger picture.
Steel has long been the go-to material for industries that require strength and durability, but this strength comes at a cost, literally. In 2022 alone, the global steel market was valued at over $1.6 trillion, with industries like that, automotive, aerospace, and construction all spending billions annually on steel components alone.
For example, the automotive industries alone spend over 200 billion per year on steel.
Resistance and mechanical durability, also leading to longer lasting, more efficient transport solutions, making this an economically and environmentally sustainable alternative.
This is not a just small improvement. It's a potential game changer of industries worldwide.
But the impact of this technology goes far beyond the laboratory.
In the automotive industries, manufacturers are constantly looking for materials that are both lightweight and strong to improve fuel efficiency and safety. Within this aluminum SiC composite, we can create stronger engine components, more durable structure frames, and parts that can engineering where every gram matters. This composite can be used to develop aircraft structure that endure extreme temperature and high loads while maintaining their lightweight nature.
The shipbuilding and railway industries also stand to benefit, as this
It's okay. These composites.
as these composites offer enhance corrosion resistance, wear resistance, and mechanical durability, leading to longer-lasting, more efficient transport solutions. But the applications don't stop there. Imagine using this technology in biomedical implants, where strength, durability, and biocompatibility are absolutely crucial. The possibilities are endless. By reinforcing aluminum's properties, we can open a door to a future where materials are not only lighter and stronger, but also more efficient and cost-effective.
We demonstrated in this study is a low-cost, highly effective methods to enhance aluminum properties using size nanoparticle and friction-stir processing. From here and out, we can only develop stronger, more durable materials without adding extra weight or cost. So this is just the beginning.
And so I leave you with this thought. If we can take such a common material like aluminum and transform it into something stronger, tougher, and more resilient, what else in material science could we revolutionize next, and how far can we go? I've been Radan Mohammadsalehi from Hakim International School.
And I've been Kaveh Ahmadipour from Hakim International School.
Thank you.